Well, I hope you had a lot of fun with these pieces in the last lesson, because we're going to continue looking for patterns with these base 10 pieces. And we're going to figure out the magnitude of the pieces as we compare smaller pieces to bigger ones. Let's get started with Lucky Lesson 7. How can place value help me see relationships between numbers? Here are targets for today. Math Marble will recognize and describe patterns in place value and describe the relationship between two numbers using multiplication. And as always, please make sure you have these 3 things so you're ready for today's lesson. And you might need your headphones. And as always, if you see those 2 symbols on the bottom right corner, hit pause and pick up your pencil to make sure your notes look like ours. All right, we're gonna go back to our base 10 pieces and we're gonna try and look at some of the relationships between the pieces. And this may have come up in your mind in the last, or maybe you've used these before. But we're gonna try and figure out the relationships between the sizes. I'm gonna start from the smallest to the biggest, our bits and our skinny. And just by looking at them, you may notice the little grooves that are here in this piece. And it's because it's supposed to be a representation. And I can actually take some little bits and I can tell you that it takes me 10 of these little bits to make just one skinny. So you see how they have the same space and size, they take up the same area and the same volume. So it takes 10 of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, just to make one of these. So we're gonna write that down. It takes 10 just to make one. And if I want to figure out the relationship between these skinnies and this flat, same thing, it also takes 10 to have the same size. Okay, there it is. So you can see I covered it all the way completely, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And they are completely covers it. So 10 skinnies to make one flat. And now if I want to figure out my relationship between these flats and this old block, again, you can see I can kind of layer it like a cake. It would take 10 layers. 4, 5, 6, 7, 8, 9, 10. So boom, there you have it there, exactly the same size, flat right on top. So it takes 10 of these flats just to make one of these blocks. And you can figure out all kinds of relationships. So if it takes 10 of these just to make one of these, how many of these pieces will it take to make this big piece? Or even to make this bigger one. Use what you know about relationships, because we're gonna figure out how many, and you might figure this little guy over here, ooh, it takes quite a few. It actually would take 10 rows of 10, because we know 10 of these makes one of these, and we know 10 of these makes one of these. So we know that it would take 100 bits to equal one skinny. So could you figure out how many bits it would take to make one block using some of these patterns? We'll talk more about this in just a second. So I just took our pieces and just replaced them, put them into a place value chart, and you can kind of see the same relationship happening, where if I want to go from this piece to this piece, from 1s to 10s, it is 10 times bigger. If I want to go from skinnies to flats, it is 10 times bigger. If I want to go from flats to blocks, it is 10 times bigger. But what happens if I want to go from, let's say I want to go from 4 bits to 400. How many times bigger is that? If I were to compare those numbers, it's not just 10 times bigger, it's actually 10 times 10 times bigger, because I'm making 2 shifts. So just think about it. I'm going from my 4 is going from the 1s place to the 100. So I'm moving once, twice. So that makes it 100 times bigger. 400 is 100 times bigger than 4. Or what if I wanted to go the other way around? If I wanted to say, how about if I wanted to compare 5 of the blocks, 5,000, to 500 if I want to compare these two together. Notice I'm going back one shift. So that means it is 10 times smaller than the other one. But if I wanted to think about it as multiplication, I wouldn't multiply it by 10 because that's going to make it bigger. It is 1/10 the size. We're going to talk about this a little bit more because that sounds really confusing. So let's see it in another example. Okay, in this session, you're going to see me compare two numbers and a value. So I'm going to do these 3 steps. 1, I'm going to write the number on a place value chart. You're going to see me circle the digits that I'm going to compare. Then 2, I'm going to count the number of shifts between the 2 digits. How far away are they on that chart? And 3, I'm going to express the difference as a multiplication sentence using the number of shifts. I already put my place value chart there so I can have it. Let's put my numbers in there. I'm trying to figure out what is the value of the 4 in 153,000. So let's put that in there. 458. So let's circle that 4. And I'm trying to figure out the 4 in 192,946. So here's my second 4. So these are the two that I'm comparing. And I'm going to just think about the digits between them. So if I want to go from here to here, how much more? I'm just making one shift. Notice I'm just going one place over. So I can tell that this one is 10 times bigger than the other one, than the second one, because it is one place over. So I'm going to put that in a number sentence here on the bottom. The 4, it has 10 times the value of the 4 in here. And that makes sense to me because I know that the 400 is equal to 10 times the 40. Let's try a second example and I'll do the same thing. Let's make my chart. Let's see, here are my ones, here are my thousands, and I just split it in two. So I'm going to put my first number in there, 3,419, and my second number, 769,182, and I'm trying to learn about the 9s in this one. And just looking already, I know that this 9 is smaller than this one. So, and how many times smaller? 10, 100, 1,000 times smaller. So how am I going to represent that? It has 1,000th the value. So because it's smaller, it is definitely a lot smaller. It is 1,000 times smaller. So notice how I'm just writing 1,000 as a fraction here, and that makes sense to me because 9 would be equal to 9,000 times 1 over 1,000. And when we get to this a little bit more, and when we get to some more fraction work, we'll actually learn how to multiply this, and we'll be able to see that 9,000 divided by 1,000 is equal to 9.
How do I compare two numbers using multiplication? I thought we were doing place value.
You're right, you are comparing these numbers and we are using multiplication because we are recognizing there is a relationship between the two. So when I look at 5,000 and I look at 500, yes, I can compare and just say that this number is bigger than this one. But place value is much more rich, and we're really learning a lot to go in even deeper and to see that there's even more than just saying one number is bigger than the other. I can tell you how many times bigger it is because they both have that 5. So again, just imagine if I just had 5,000 and I looked at 500, I know that all I would have to do is move this just one place over. If I just moved it one place over, they would be even. So in order to do that, and I'm just going to show it to you right underneath it. So here's 500. If I put them right next to each other, you can really see if only this had another 0, they would be the same. And when we add a 0 to the back of a number, it's the same as saying times 10. So I want you guys to think about that. So if I just had that 500 and then multiplied it by 10, I would have 5,000. So that's telling me that 5,000 is 10 times bigger. Is 10 times greater than 500.
What if the numbers are getting smaller? How am I supposed to use multiplication to show things getting smaller when things get bigger when we multiply?
This one's a big leap of faith because when we think of multiplying, we think of numbers getting bigger. And we are definitely going to go into this when we get into fractions. We already know that 30 is way smaller than 30,000. So again, if here's 30 and here's 30,000, I'm just lining them up so you can see. We know that I would need 3 zeros in order for them to be equal to each other. So for me to have 3 zeros, I would have to multiply this by 1,000. Again, 3 zeros. In order to make that true, we're going to multiply it by 1,000 because then I'm going to have 30,000. So this 30 is a lot smaller than the other one. So it is 1,000 times smaller than 30,000. Okay, so it's not 1,000 times because I would make it very, very big. It's 1,000ths, meaning I'm going to get very, very small. And this is going to be a little bit of a preview of what we're going to do, and I don't mind showing it to you, and it's okay if you don't really get this right now. But if I took 30,000 and I multiplied it by 1,000, I'm going to get 30,000 over 1,000. And this is how many thousands go into 30,000? 30. And this is again some math that we're going to learn a lot more about later. So all you have to remember is when the numbers are getting smaller, it's going to turn into a fraction. You're going to multiply it by that fraction. Critical thinking question. If I multiply a number by a fraction, it gets smaller. How would you explain that to a peer? Just jot this down in your notes. Try your very best, math. Well, now it's your turn to put some of this work into practice. Another base 10 lesson. I hope you found it useful and you saw some interesting patterns happening between the different numbers and you have a new way of comparing numbers in different places.